We're going to talk about radical and exponential functions. So a radical function looks like this. It has the radical symbol, and your variable is going to be inside the radical symbol. You can only plug in numbers that make the radicand positive, which means that x has to be positive numbers, which means that your domain is going to be greater than 0. So let's look at the basic graph of f of x equals the square root of x. If we were to fill out a table, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3, and the square root of 16 is 4. So if we were to go to our calculator and we were to look at the graph y equals the square root of x, we would see that the graph starts at 0 and slowly increases to the right. Okay, so that tells a couple of things. First, it tells us that the domain has to be greater than 0. Then it also tells us the range has to be greater than 0. Notice how none of our y values continue to get larger and larger. We're never going to have a negative answer. So our domain is greater than 0 and our range is also greater than 0. What about the function f of x equals negative square root of x? So our table changes a little bit because the square root of 1 is 1, but then we have that negative in front. So negative times 1 is negative 1. So the square root of 4 is 2, but then it becomes negative 2. The square root of 9 is 3, but the negative 1 times 3 is negative 3. And then the square root of 16 is 4, but the negative of that will be negative 4. So if we look at that graph, we go to y equals, and now we had to put the negative symbol in front of our square root of x. And if we look at the graph, it's almost like the graph of f of x equals the square root of x. But the difference is that it's flipped over the x-axis, which tells us a couple of things. The first thing is that the domain is going to stay the same. You still cannot have a negative x value. However, our range is a little different. Our range, although it can be 0, it's always going to be less than 0. Notice that we don't have any other positive numbers. So our range, our y values, will be less than 0. Let's look at the graph f of x equals the square root of x plus 2. So now, when we plug in 0, the square root of 0 is 0, but then plus 2 is 2. And the square root of 1 is 1, but plus 2 is 3. And the square root of 4 is 2, but plus 2 is 4. And the square root of 9 is 3, and then plus 2 is 5. And the square root of 16 is 4, but plus 2 is 6. And if we look at our graph in our calculator, we'll go to y equals, and we'll put the square root of x. And then we'll do plus 2. And when we hit graph, what we notice is that our graph has shifted. Instead of starting at 0, it starts at 2. So this tells us a couple of things. First of all, our domain is still the same. Our domain, our x values, will still not be negative numbers. So our domain, our x's, have to be greater than 0. However, our y's, we cannot have a 1 value for y. In fact, the smallest y value we can have is 2. So our y, or our range, is going to be greater than 2. Let's look at the graph on our calculators of this one. So we'll go to y equals, and this time we'll do the square root of x plus 2, but the plus 2 is going to be inside the square root. And so if we look at our graph, we notice that this is going to shift our graph to the left 2. Okay, so it tells us a couple of things. First of all, our domain, which is our x values, is still greater than 0. However, if you notice on the graph, it can actually go to -2. We can actually go all the way to -2 for our domain, okay? But for the y values will still be greater than 0. So our range is still greater than 0. Okay, so let's try this question. What is the general shape of y equals the square root of 2 to the x? Go ahead and see if you can't figure this one out. So notice this one, there's no plus and there's no plus or minus. It's not either outside or the inside. So because of that, it's going to start at the origin. Okay, it's going to start at the origin, which means number 1 and number 2 are both out of the question. Because number 1 would have to have been something like 2x minus 3 because it's, or plus 3 because it's 3 to the left. So it can't be that one. And then number 2, it looks like it's up 2, so it'd be the square root of 2x plus 2. So it's not going to be number 1 or number 2. And number 4, you notice that it's going downwards. And remember, we said that that was when you had a negative in front of the square root symbol, and we don't, which means that our answer would be number 3. All right, let's try this one, the square root of x plus 5. So remember, if you're adding something on the outside of the square root, that's going to move it up and down. So plus 5 means it's going to move up 5, which is number 2. All right, let's talk about the exponential function. And that is in the form of f of x equals some number called a to the x power. And so a cannot be 0 and it cannot be 1. But it can be any positive number and any negative number, and it also can be rational numbers such as fractions. The only restriction on a is that it cannot be 0 and it cannot be 1. So let's look at the basic graph for f of x equals 2 to the x. So if we plug in numbers, let's try x equals 0. Well, that's 2 to the 0 power. Anything to the 0 power is 1. So now let's try x equals 1. So 2 to the first power is 2. Let's try x equals 2. Well, 2 to the second power is 4. So x's, we can have positive or negative x's. So let's try -1. Okay, so 2 to the -1 power. Well, remember, when you have a negative exponent, you take the reciprocal. So 2 to the -1 is actually 1 over 2 to the 1. And 1 over 2 to the 1 is 1 over 2. Now let's try x is equal to -2. So that becomes 2 to the -2 power, but because it's a negative exponent, we're going to take the reciprocal, so we get 1 over 2 to the second power. And then 2 to the second power is 4, so we get 1 over 4. And if we were to look at this graph and plug it into our calculators, and we would say 2 to the x, and look at the graph, we would notice that it's going up rather quickly. But we also notice that we will not have any y or negative y values. All of our y values have to be greater than 0. We also notice that x can be anything, right? It continues forever in both directions. So we would say our domain would be all real numbers. We can have any x we want. However, our range will never be negative, so our range has to be greater than 0. What about f of x equals 1/2 to the x power? Well, let's try x equals 0. 1/2 to the 0 power, well, anything to the 0 power is 1. So now let's let x equal 1. Well, 1/2 to the first power is 1/2. So now let's try 2. So 1/2 to the second power, we distribute the 2. So 1 to the second power is 1. And then 2 to the second power is 4. So we get 1 over 4. Let's try x equals -1. Okay, so now we have 1/2 to the negative 1 power. So we're going to distribute that negative 1. So we get 1 to the negative 1 over 2 to the negative 1. And so remember, the negative exponents mean we're going to take the reciprocal. So 1 over 2 is going to become 2 over 1. And so 2 over 1 to the first power is 2 over 1, which is just 2. So now let's say x equals negative 2. So that means that we have a negative exponent, so we have to take the reciprocal. So 1 over 2 is going to become 2 over 1 to the second power. So 2 to the second power is 4, and 1 to the second power is 1. So we get 4 over 1, which is just 4. Let's look at the graph. So if we were to go to y equals, and we would have to put the 1/2 in parentheses and then take it to the x power, and we looked at that graph, we would notice that for our domain, our x's, it continues in both directions. So our x's can be positive or negative. So for our domain, we still have all real numbers. And then for our range, it looks like our range can be any positive number greater than 0. So our range is still y's that are greater than 0. Let's take a look at the graph f of x equals negative 2 to the x power. Notice the negative is on the outside, so we're going to do 2 to the x power first, and then we'll put the negative in front of it. So 2 to the 0 is 1, and then add the negative, we get negative 1. 2 to the first power is 2, but then times the negative, we get negative 2. 2 to the second power is 4, but with the negative, it's negative 4. 2 to the negative 1 power becomes 1 over 2, and with the negative, it becomes negative 1/2. And then 2 to the negative 2 power is 1 over 4, but then with the negative, it becomes negative 1 over 4. So let's go ahead and put that into our calculator into y equals. So we have the negative first, and then we have 2 to the x. So you might want to put the 2 to the x in parentheses. And when you graph it, you'll notice that we still have any x value we want. We can have positive or negative x values. However, our range is a little different. It has flipped over the x-axis, which means that all of our y values have to be negative. They have to be less than 0. So our range is less than 0 now. All right, so here's something to know about exponential functions. The basic exponential function will cross through the point 0, 1. So again, it's not going to go to the origin like the basic radical function goes to the origin. The basic exponential goes through 0, 1. And so when you have an a value, which is the base, that's bigger than 1, it's going to go up to the left. However, if a is a fraction, then it's going to go up to the left. So I'm sorry, if a is greater than 1, it's going to go up to the right. However, it's between 0 and 1, it's going to go up to the left. So if you have a negative sign, it's going to flip the graph upside down. So let's try an example. What is the general shape of 4 to the x? So 4 is greater than 1, which means it's going to go up to the right. It's not negative, so it's going to be going up. So up and to the right would be number 2. What about negative 4x? Well, remember, when it has a negative in front of it, it's going to flip it upside down, but it's still going to be going to the right, which is number 4. What about 1/4 to the x? So your a value is now a fraction, which means it's going to go up to the left, which is number 1. So now it's your turn. You're going to try 7.7, 2 through 6 evens.